All right, I'm going to conclude section 14.2 in this section 14.2 in this video by going through and evaluating the integral for problem 6, page 921. 921. We set this integral up in a previous video, but for sake of time, I didn't evaluate it. So I'm going to quickly go over how to evaluate this now. I'll get you all over any sticking points, and then you can finish it off from there. So we had r squared times cosine squared theta times r dr d theta. All right, so this is really r cubed here. So when we integrate with respect to r first, we're going to get this equals the integral from 0 to pi of r to the 4th over 4 times cosine squared theta. And our bounds were from 0 to 4 sine theta. And then we still need to integrate that with respect to theta. So now when we put this in, and remember we're putting this in for r, so we're going to end up with r, 4 to the 4th over 4, which is 4 cubed. So I'm going to just put that on the outside. And then the integral from 0 to pi. And now when I put in the sign, I just handled the constant separately. So sine to the 4th, the over 4 is gone. I handled that right there. So it's just a sine to the 4th now of theta. And then times cosine squared theta squared of theta. All right, and then minus when we put in 0 for, this 0 right here, minus when we put in the 0 for r, not for theta. Be careful with that. So we put that in for r, which means this whole thing's going to go to 0. And we end up with d theta right there. All right, so now we need to integrate this and this. Now we have to go back to some trig identities to evaluate this integral. So we end up this equals 64 times sine squared theta. So I'm going to write this of the integral from 0 to pi of sine squared theta. And I'm going to take the other sine squared and put it with that times sine squared theta cosine squared theta d theta. And I'm going to use two trig identities. So sine squared theta, that is the same as 1 minus cosine of 2 theta all over 2. And then sine of theta times cosine of theta. So sine of theta times cosine of theta is 1/2 sine 2x. So this ends up being 1/2 sine of, theta, not x. 1/2 sine of 2 theta squared d theta. So now with this, if I go through and I simplify this, so I have 2 is going to come out in the denominator there. Here a 4 is going to come out in the denominator, so I'm going to have 64 over 8, which of course I could simplify that, but oh well, I didn't. I don't know why I didn't, but now the integral from 0 to pi, if we multiply everything out that we have here, we're going to end up with sine squared theta right there, and we're going to end up with, because that's going to end up in, remember my fractions are gone, so sine squared theta times the 1, and then minus sine squared theta times 2 theta, sine squared of 2 theta times the 1, and then sine squared of 2 theta times cosine 2 theta. Goodness, I did it again. 2 theta. There we go. Then minus cosine of 2 theta times sine squared of 2 theta. There we go. D theta. And now I think you should be good to go here if you just let u be equal to, so over here you're going to use a trig identity again. So actually I'll take you one step further. So 64 over 8 with 8, and then the integral from 0 to pi. Here you use the same trig identity that we used earlier. So this is 1 minus cosine of 4 theta over 2 d theta minus 8 times, so here for this integral, if you use a u substitution, u equals sine of 2 theta. U equals sine of 2 theta. If you use that back here, you would get du then is equal to 1/2 cosine of 2 theta, or 2, excuse me, cosine of 2 theta d theta. 2 cosine of 2 theta. Sorry, if I can squeeze my d theta on the screen. D theta. Sorry about that. All right, so now that gives us du over 2 is cosine 2 theta d theta. So cosine 2 theta d theta is du over 2. Our bounds were 0 to pi. And then u squared du. And just remember to change, back substitute your u, and I'll let you all finish that part off from there, because now this is a fairly straightforward integral of 1/2 with respect to theta, and the integral of cosine 4 theta with respect to theta. All right, so that concludes section 14.2, and we'll start section 14.4 in our next video. We're going to skip section 14.3 because that information will be covered in a subsequent section.